Side it will not move. Outer ones are the ones that usually move, and these are subject to like very high temperatures. So we need to cool it. If not, it'll start melting. As a reason why, you can see from here, you have holes over here. You send pockets of air, and the air just circulates inside. So whenever the temperature is very high, the air will absorb the temperature and then send it out. So you will keep these blades very cool, and it will not tend to melt. However, in case the air circulation fails, these blades are nowadays designed with materials to withstand temperatures of like 3000 Kelvin. The temperature in a combustion chamber can essentially reach like 2500 Kelvin. It's so hot that the energy is so much. And the function of a turbine is to extract that energy. And a turbine is connected to the fan. So the outer part of the turbine is connected to the fan. So if I move the turbine over here, the fan will move. Because it's sitting on the same shaft. So and the air that comes with such high velocity will turn this guy. So when this guy turns, that guy will turn. And inside here is like another part that will move this. So when this rotates, that will rotate. So what you can think is turbine will drive the compressor, and a compressor will start sucking in air and start to compress the air. However, when the air is compressed, you will tend to have pressure loss. Loss in pressure is not good for the industry. So to prevent that, we do different mechanisms. Like we add a booster stage. A booster stage will essentially kick the pressure back up. And this engine does have a booster stage, but you can see from front. Booster is a very tiny radial part. And these big pipes over here are the fuel manifolds. So when the air enters a combustion chamber, you need fuel to burn it, right? So in a car engine, you kick the ignition, the flame comes in, the fuel is there, it starts burning. So the fuel, when the air enters here, there are like sprays on top. Around this engine, there are like nozzles. So when the air is sitting inside, it will start spraying the fuel. And down there, these pipes over here inside, we have the ignition. So when the sensor detects the temperature is high enough, it will send the spark. It's like half a millisecond. The blink of an eye will start combustion. And another use for the compressor is like when the air is flowing through very fast, because usually an aircraft will fly at Mach 0.8, which is like Mach 1 is the speed of sound. Speed of sound is 330 meters per second. So this aircraft will fly at about 280 meters per second. It's very fast. Every second it will come 280 meters. It's very fast. So when the air is moving very fast, combustion is very hard. To burn something, if it's going very fast, you have no time. So the purpose of a compressor is to slow down the flow. So when it slows down the flow, there is more time for you to react with the fuel and burn. So once it's burning, the turbine will accelerate the flow. Turbine and compressors are like opposite. They always contradict each other. But this one will drive that one. They need each other and they can't be without each other, but they do opposite jobs. And the turbine is always thick, very thick. So because since the velocity is very high over here, lots of stress. So like if you're having this thing sit and you're blowing, it's going to hit like that. So you need to be very strong. That's why it's very thick over here. So engine is always compressor, combustion chamber, turbine, and the rear part is called the nozzle. Where exhaust to that. And when it exhausts, it has to be completely straight. This is a commercial jet, which means, and this produces 42,000 pounds thrust. But you see the Boeing 777 that runs on the GE90 engine, that produces 115,000 pounds, which is like 3 times this. And that is like small, much smaller than this, because technology has improved, and this was in use in the 1960s, 50s, 60s, very old. This was used in the DC-10. So, and it's pretty big, but it's very inefficient. And if you look from here, this is the outer part on the other side, and these are like what you call very heavy stuff, where the compressor will fit into this. So this is what you call the fir tree design. It looks like a fir tree, like a Christmas tree, and you could hold this and see. It's very. Want to try? It's very heavy. So there are like 14 of these. You can imagine how heavy an engine is. And so these are like parts that we removed. This is one part of the fuel injection system that connects, so fuel will flow through this and inject inside. So this is what you call the spray. You can see it's very tiny, so it will just start spraying like that to increase area and combustion. So there are like little stuff that need to be taken into account when designing the engine. For instance, this is the actuator. Also can be used as a pneumatic piston. This will sit on the side of the thing. So very old, so you can see like very inefficient. Nowadays actuators are like that. Right? This is like pretty huge. Because when we are transporting the engine, it started to leak fuel. So to prevent the fuel from leaking only, we tight with aluminum foil. But now there's no fuel, you can remove it. You can go ahead, get on there, touch whatever you want.